This is part 2 of a 4-part series. Hello and welcome. My name is Dave Cranon and I will be your host on this tutorial. NICET Level 3, exam number 10014, hydraulic calculations. Formulas to know: how to convert head to PSI or foot to PSI. PSI is equal to 0.433 times the head of 100 feet equals 43.3 PSI. 2. Convert PSI to head. Head feet is equal to PSI times 2.31 feet. So our example is 43.3 times 2.31, which will equal 100 PSI. Number 3, elevation changes. Increased elevation plus 10 foot times 0.433 equals velocity pressure, PV, flow that moves in pipe acting parallel to the pipe walls when fluid is moving. The formula for velocity pressure is 0.001123 Q squared divided by D to the 4th power. Velocity pressure is usually small enough that it can be ignored in most hydraulically calculated systems. The working assumption is that the total pressure is the same as normal pressure. Total pressure is equal to velocity pressure plus residual pressure. Table 23.4.3.2 is a C value multiplier, and remember 120 is the basis. Table A.6.3.2 is for steel pipe dimensions. Table A.6.3.5 is for copper tube dimensions, type K, type L, and type M. Hydraulically designed systems is a calculated sprinkler system in which pipe sizes are selected on a pressure loss basis to provide a prescribed water density, a prescribed minimum discharge pressure, or flow per sprinkler, distributed with a reasonable degree of uniformity over a specified area. For hydraulically designed systems, we need to calculate losses through pipe, fittings, valves, etc. Consider all when determining the pressure losses for hydraulically designed systems. Whether hand calcing or using a computer software, you must know the different friction loss and C values for Hayes and Williams. This table, 23.4.4.8.1, is for the Hayes and Williams C values. For example, black steel for a wet system, including deluge, is 120. Friction loss and C values. Hayes and Williams coefficient conversion factors. C value multiplier. Conversion guide for changing from one Hayes and Williams coefficient to another. Simple multiplication factor. Use when appropriate. For C equals 140, use multiplier from table below and multiply by pipe's equivalent length. For C equals 140, factor is 1.33, increasing the equivalent length of the pipe segment. For C equals 100, follow the same process. Multiplying factor is 0.713, decreasing the equivalent length of pipe segment. Table A.6.3.2 steel pipe dimensions provides the outside and inside diameters and wall thickness of steel pipe ranging in nominal size from 1/2 inch to 12 inch for the following: Schedule 5, Schedule 10, Schedule 30, and Schedule 40. Be aware that the use of backflow preventers can cause significant friction loss in a system. Some manufacturers may provide the friction loss in terms of the actual loss associated with that device. Let's work an equivalent length modifier example. Calculate the equivalent length for a 4-inch Schedule 10 standard 90-degree elbow. For internal pipe diameters different than Schedule 40 steel pipe, Schedule 30 for pipe diameters 8 inch and larger, use the formula below found in NFPA 2016 section 23.4.3.1.3.1. page 13-264. Schedule 10 steel pipe inside diameter is 4.260 inches. Schedule 40 steel pipe inside diameter is equal to 4.026. We take the actual inside diameter and divide it by Schedule 40 steel pipe inside diameter to the 4.87 power. Continuing our equivalent length modifier example, we have Schedule 10 pipe diameter divided by Schedule 40 pipe diameter to the 4.87 power. This gives us 4.26 divided by 4.026 to the 4.87 power, and that will give us a factor of 1.317. We multiply the 1.317, the factor, times the equivalent pipe length of 10 feet, and that will give us an equivalent length of 13.17 feet. Reference NFPA 2016, Table 23.4.3.1.1, page 265. At this time, I would like to review hydraulic calculations procedures. Identify the classification of the occupancy to be protected. Determine the required design density. Determine the sprinkler operation area. Determine the number of sprinklers in the design area, or most remote, or most demanding. Determine the shape of the design area, 1.2 rule. Determine the number of sprinklers per branch line. Calculate the required minimum pressure for the first sprinkler. Calculate friction loss between the first and second sprinkler. Calculate the flow from the second sprinkler. Calculate the pressure for the sprinkler. Repeat these hydraulic calculations for all operating sprinklers on the branch line in the most remote area. Problem 1. Determine the velocity pressure in PSI for a 2-inch Schedule 5 steel pipe with a flow rate of 25 gallons per minute. Is it A, B, C, or D? Determine the velocity pressure in PSI for a 2-inch Schedule 5 steel pipe with a flow rate of 25 GPM. The solution. Number 1, using the following formula to determine the velocity. PV, velocity pressure, is equal to 0.001123 times Q to the square power, divided by D to the 4 power. Step 1 again, we using NFPA 2016, Table A.6.3.2, the internal diameter of a 2-inch Schedule 5 pipe is equal to 2.245 inches. Using the information given in the problem statement, determine the velocity pressure. Q is equal to 25 gallons per minute. D is equal to 2.245 inches. Therefore, velocity pressure is 0.001123 times 25 squared, divided by 2.245 internal diameter to the 4th power, and that'll equal 0.001123 times 625 divided by 25.4. So our velocity pressure in this problem is 0.028 psi. Problem 2. Determine the K factor for a 10-foot branch line delivering 75 gallons per minute at 30 psi at the top of the riser nipple. Is the answer A, 13.7, B, 25.8, C, 19.9, or D, 18.7? Problem 2 continued. Determine the K factor for a 10-foot branch line delivering 75 GPM at 30 psi at the top of the riser nipple. K is equal to Q, water, divided by P, pressure, the square root of P. So K is equal to 75 gallons per minute divided by the square root of 30 psi, and that'll give us a total of 13.7. So the correct answer, the K factor, is 13.7. Problem number 3. Determine the maximum operating pressure for an extra hazard Group 2 sprinkler. A, 25 psi, B, 50 psi, C, 100 psi, or D, 175 psi, or does it depend on storage height? The correct answer for problem number 3 is 175 psi. Per NFPA 13 2016 edition, section 23.4.4.12, the maximum operating pressure for an extra hazard Group 2 sprinkler is 175 psi.